Okay, so we're going to spend some time reviewing for your quiz, just like last time. I'm not going to give you the information that you're going to be tested on, but I'm going to tell you where to locate that information in your resources. When you go off to college, this is even more hand-holding than you'll already get. I mean, when I was still around, I was telling you everything that you were going to need to know for the test. Now I'm telling you everywhere you can find those things. When you get to college, it'll just be expected that you can filter the most important things and create your own study guide and I guess look through your materials and decipher, oh, what is continuously repeating? What is a theme? What is it that the instructor or the professor wants me to know? So gradually over time, I'm holding your hand a little bit less, expecting you to figure this stuff out on your own. You will be able to create a study guide for yourself if you follow along with this and locate the information in your resources. But I don't want you to expect me to just give you things that you already have. That's been a theme I've been trying to stick with all throughout the year. Just give you the ability to find the information rather than hand it to you. So, our lecture notes, as usual, have the same format. I'll give you the main idea and the questions. You're going to have to come up with the content that fills in here, which is 70% of your grade. Remember, you get 1 point for the main ideas that I'm going to give you, 1 point for the questions. I'm not going to write them, but I'll say them. 1 point for the summary, and you are going to have to fill in the notes here. I'll tell you where to find the information though. So here we go. We got your main idea, our main ideas. That's 1 point. And your questions. That's another point. So in looking at my reference, there is 1, 2, 3, 4, 5, 6, 7, 8, 9 main ideas. I expect you to have that many main ideas, and I'd say probably 5 sentences in your summary. A couple of them go together, like lenses and mirrors you could probably lump together, or reflection and refraction you could probably lump together. So speaking of which, let's cover your first main idea, reflection. So you could write a question as simple as what is reflection, but that's pretty weak. I don't really think that's going to help prepare you. You're not going to have a question like that on your quiz. Instead, you could ask some sort of question like, how does light behave when it's reflected off of a surface? That is something that you're going to have to both explain and illustrate. So the places where you can find information on reflection is your pretest, number 13. If you write that down on the question about reflection, pretty much what's in that question on number 13, you'll get a point. I'm going to ask you to explain the process of reflection. I'm also going to ask you to illustrate it. Where you can find this illustration should be from your simulation. I believe it was number 1. Your reading notes. Number 15. Yeah, the videos and articles, or the video and article. There might have been more than one, depending on if you did Kahn or Bozeman or read the article, or you haven't done any of it yet and you're now thinking maybe I should have, which is probably a lot of you. On 4.4. And then also the do nows and reflections got a little flipped around, but I'm pretty sure the one on 4.3 it covered reflection, absorption, and transmission. So this is everything that you have which covers this main idea. So you should easily be able to both name the process, or name what happens in the process of reflection, illustrate a diagram, and that diagram should have labels. Those labels should correspond or go along with the diagram that you draw. So I'm not going to draw it for you down here. That's what I used to do. But what you should be doing is stating what it is, showing what it is, and making sure that your picture has some labels to help show what's happening there. Okay, that's it for your first main idea, reflection. Your next main idea, so this is just a continuation of the same notes. You know what goes here. I'm just going to try to abbreviate it to speed through this. Main ideas and questions, that's what this stands for. That's an M in case you can't tell, is refraction. Refraction was, whoops, kind of like a big theme all throughout this. Every time we were talking about lenses, light was being refracted through them, and also dispersion. But refraction is a huge main idea. So the resources that you have at your disposal to help you explain and illustrate, similar to what you're doing with reflection. Number 14 on your pretest, on your simulation. Jeez, sorry about this. Oh boy. Your sim, come on. Okay, what's going on here? Sorry folks. Your simulation, numbers 2 and 3. Your reading notes, number 16. So I'm going to try to start abbreviating things here to speed this process along. It's number 16 on your reading notes. You had a video and an article that you could have read from April 5th. And finally, there was a do now from, looks like 4:10. And if you think about it, all the stuff when we were talking about lenses really had to do with refraction as well. But when it comes to just general process of refraction, this is everything that you could use. Your pretest, your simulation, your reading notes, the videos and articles, and the do now. So just like reflection, you're going to have to illustrate the process, you're going to have to explain it, and you're going to need some labels. Both with reflection and refraction, those labels should be of the angles. So you want your labels to be kind of quantitative. You know, when something refracts through a substance, you could use angles to explain what's happening. And when something reflects off of a surface, you should be using angles to explain what's happening. Okay, next main idea. So, going back to refraction, you know, when it comes to your question, you just ask, explain what happens to a ray of light as it passes through, well, I don't want to tell you the answer, but explain what happens to a ray of light in the process of refraction. So for the next one, your main idea is polarization. So you probably don't have too many resources on this one. It's a pretty simple process, but you could ask what happens to a beam of light or a ray of light or even a photon, a particle of light, or a wave of light as it is polarized. So the process of polarization was introduced to you on your pretest, number 9. I think there was a really good diagram in your book that went over this. So check out your reading notes, numbers 11 and 12. And if you have that book at home, like if you're have the book in front of you now during class, you want to go grab it up, check it out, or you just have it at home and you want to remind yourself, whatever page you got the information from 11 and 12, there was a really good picture with a rope and a fence that helped make an analogy for what happens in the process of polarization. You really need to think about light as a wave in order to understand polarization. And it really has to do with vibrations, which is what characterizes all waves. There is a video and an article specifically centered around the process of polarization. This was from April 3rd, and you had a do now that was covered on April 6th. So when it comes to this question, I believe this is just a two-pointer. You just have to explain the nature of a wave before it is polarized and how it is changed after it goes through the process of polarization. So that could also help you formulate your question. How is a wave changed after it has been polarized or after it has gone through the process of polarization? You know, as you look through all of these things, you're going to see a lot of overlap, a lot of repetition, and that's good. That's what happens when you study. It's like, you know, when you're practicing, you do the same thing over and over and over again so that when it comes time, when it counts the most, that's when it's the easiest for you. That's what you want to do right now, is review this material so many times that by the time the test is in front of you, it's a breeze. You're not thinking about it. It's already up there in your brain. Okay, next process. We've covered reflection, refraction, polarization. The next main idea and question that goes along with it should be about dispersion. You did talk about diffraction a little bit. I don't want to test you on that one. That was at the beginning of the unit. Had to do with like wave interference. Forget about that. It's important to understand it when we were transitioning from waves to light, but now I want you to know about dispersion. So dispersion is a pretty complex process. I'm not going to test you on all of the details of what's going on, but when it comes to how to define it, your pretest number 15 introduced it. You got a pretty good example of it from your simulation, number 13. Your reading notes, number 17. And there is a Khan Academy video completely dedicated to this. And there might have been an article as well, but I found a Khan Academy video that was all about the process of dispersion introduced on 4.5. And you know, one thing that I forgot to mention, it doesn't go with polarization or refraction. Well, I guess kind of refraction when you're working with the lenses. But your light box lab, you saw dispersion occurring. So you're going to need to name this word to answer a question. I'm going to ask you about what happens when light passes through a rectangular prism. Kind of just gave you a point on your quiz right there. But I also want you to describe why it happens. And the do now from, looks like I missed that one. You did have a do now on dispersion. Let me see if I can locate that. Well, this might take longer than I wanted to. So I apologize. I thought I had all my ducks in a row here. There is a do now on dispersion from last week. I think that Mr. H and I decided on this at the last minute, which is why I don't know. It might have been Wednesday and Thursday, or possibly Tuesday, but you do have a do now all about dispersion, and I know he went into great detail about it. So study up on that and watch that video if you're still confused about it. It's pretty complex what causes it, but it all just has to do with the amount of interaction for each frequency of light and how things that interact more end up taking longer to get through the prism, which means they get refracted more. So kind of gave you a lot of the answers for this one, but just do your best to describe the process and make sure you know the name of it in order to get those 2 points. You need to name it and describe it. Okay, next process. And all of these processes are what happens when light interacts with different substances. The main idea and question on this one should be all about absorption. This is a really important one, and this kind of relates to the next main idea about the color equations. So when it comes to the process of absorption, and I feel like this was probably in your vocabulary before we started this unit on light, the word absorb is used often, and it's not just about light. But pretests, numbers 12 and number 8, go into the process of absorption. Your reading notes, ooh, number 10. There was an article on April 1st all about absorption, right at the beginning of the unit. And there was a video on April 4th. I think the video covers absorption, transmission, and refraction, so there's more than what you need there, but it'd probably be easy for you to locate just the part about this main idea. When it comes to the question, what happens to light when it is absorbed by a substance? And there was a do now on 4.3. I think the do now on 4.3 also covered reflection, transmission, absorption. This should be an easy one, but I'll give you a little hint on this one. I want you to describe the energy conversion that occurs in the process of absorption. So just think about what happens when you're wearing a black sweatshirt. Everybody knows how it feels, hint, hint, when you're out in the sun. What type of energy is the light made out of? Well, just go back to the beginning of the unit. It's a specific type of wave. And what type of energy that light transform into, you can feel it, especially if you're wearing a black sweatshirt. So you will have to know the energy conversion. It's going to be like this type of energy changes into this type of energy in the process of absorption. Should be simple and straightforward. We've been talking about energy conversion since late September, early October. Okay, so the next main idea, is going to be about looks like my computer is running pretty slow here. So your main idea and questions is going to be about the color equations. I know this was put up on the board yesterday, and because the video was so long, you might have had a hard time actually discussing it. It's pretty straightforward, and I'm going to do my best to kind of walk you through this as easily as I can, and maybe use some color coordination to make it clear to you. But you need to know that red, green, and blue are the primary colors of light. Now, when you add all those together, what you get is, and I can't write it, but you get white light. Now, if I was to subtract red from white light, I'd be left with a specific pigment. If I was to subtract green from white light, I would get a different pigment. And if I was to subtract blue, I would get another pigment. So those three pigments, those are words that you would be able to locate if you looked at your simulation numbers 15 through 20. So you get a lot there. You'd want to look at your reading notes, number 13. And you'd want to look at your Lightbox lab. And finally, the do now from yesterday, which is 416. So the other thing that you need to know is not just when I add red and green, what do I get? When I add red and blue, what do I get? When I add green and blue, what do I get? I want you to know what happens when you subtract. So this one, I'm going to make it a little bit more straightforward for you. White minus each one of these is going to give you one of those pigments. So I'm going to try to help you out a little bit more with this one because there wasn't too many resources on it. But if I subtract red from white, what am I left with? Well, if white is red, green, and blue, all I'm left with is green and blue. And what happens when you add green and blue? You should know by now. Same thing. What happens if I subtract green light from white? So all I'm left with is red and blue. What happens when I have red and blue added together? You should know what goes right here. If you don't, check out the resources that I have put over here for you. And then finally, what happens if I subtract blue from white light? What am I left with? I'm left with just red and green. What happens when you add red and green together? What pigment do you see? Or what secondary color? So you might be wondering, what does this physically mean, all of this subtraction? Well, that's what happens in absorption. All of these right here, anything that absorbs blue light is going to be leaving behind a specific pigment. Anything that absorbs green light leaves behind a specific pigment. Anything that absorbs red light leaves behind a specific pigment. Now we're just talking about the most simplistic cases. In reality, it's always combinations of these that leaves you the array or the wide variety of colors that we have, both in the rainbow and in the color wheel. So all of those colors really are just a combination of red, green, and blue, or not just a combination, but a subtraction of different, I guess, variety of red, green, and blue. So some of the blue goes away, which makes it a different color, versus maybe some of the blue and some of the green gets absorbed. So, and why it's absorbed, it all has to do with what's going on at the subatomic level, which I'm hoping at this point you understand, but I'm not going to test you on because it gets pretty complicated. I think it's covered pretty good in your reading notes, and also I guess when we, in the process of absorption, they really talked about it, but different materials absorb different frequencies. All of the different colors are different frequencies, and that explains the process of dispersion as well. So all this stuff is connected. Okay, I'll shut up about the different color equations. Moving on. So the next main idea is a huge one. The biggest main idea in this unit probably. And not so much because it's the most important, but because it's kind of where a lot of the ideas cross. So this next main idea which should be accompanied by a question. And on your little last question, you could ask, I don't know, how can different colors of primary light be combined or absorbed to result in the secondary pigments? The main idea for this one is lenses. So there's two major types of lenses. There's a lot of questions related to lenses on your pretest. The specific types of lenses are contained within this range of questions, but there's also many questions about how lenses change light or what gets formed due to the way that lenses or light interacts with lenses. So check out pretest number 16 through 23. I don't expect you to write down every single one of those answers or questions in your notes, but you should thumb through all of your resources and then try to decide what is the most important thing for me to be writing down here. Your simulation notes, those questions of 8, 9, and 11. I'll go over the things that you could be tested on when it comes to lenses. You are going to have to draw some pictures, label them, and explain what's happening. Both the lenses need to be labeled, and the way that the light is behaving after it interacts with the lens needs to be explained in a caption. Your reading notes. So numbers 18 through 25. Again, lots of information covered here. You don't have to write down every single thing, but you should be looking through it and trying to figure out what is it that I'm most likely going to be tested on. And it's going to be the thing that pops up in all of these resources, whatever overlap you see. Obviously, your diagram on lenses and mirrors, you're pretty much going to have to draw every single thing in that diagram. So make sure that that is finished, you understand the rubric, because I'm pretty much using the point system on the rubric to grade these. So make sure that you're going to be able to draw what's happening in your diagrams on the day of the quiz, which could be tomorrow for some of you and Thursday for others. The videos and the articles on 4.8, the lab, and then let me jump up to the top here because I'm running out of room. The do now on 4.11. So lots of resources when it comes to lenses here. I would suggest that you look over everything. Try to decide what are the reoccurring themes. There was some stuff that was covered in many of this that you won't be tested on, and you'll notice that because it won't pop up repeatedly. But the things that are covered in every single one of these is something that you're going to be tested on. And the question that you could be asking right now is maybe what are the different types of lenses? How does light behave when it passes through a lens? What type of images are formed by lenses? You're going to need to know all of those things on the day of your quiz. Okay, next main idea. Similar but not the same. A lot of the concepts are reoccurring, except for instead of light passing through or being transmitted, it is being reflected. So you probably at this point you can probably guess we all know how to see our reflection. What do we look at? Mirrors. So question you could ask, similar to the last one, how does light behave when it interacts with different types of mirrors? What are the different types of mirrors? The same pretest questions that I mentioned last time. Numbers 16 through 23. The word lens may be in many of those pretest questions, but it can be replaced with mirrors, and for the most part, you're going to get the exact same type of answer. Let's see here. The lenses and mirrors diagram. So Lenses and mirrors could be lumped into one sentence in your summary. The only thing that's different is whether or not light reflects or refracts. There's 2 days worth of videos and articles. So if you didn't check out any of those and you're not too confident about mirrors, it's not too late for you to revisit the resources that have been provided. And if you finish the quiz and you feel like you're going to have to retake it, I would suggest that you watch all of the videos and read all of the articles in preparation for your retake, which will happen next week right before I submit grades. And you want to have a positive impact on your grade. For when it comes to mirrors, it should have been today's due now, so this should be fresh in your brain. So this is everything for mirrors. You're going to have to draw 2 types of mirrors, illustrate how light behaves when it interacts with those 2 types of mirrors. You're going to have to label those 2 types of mirrors, and you're going to have a caption explaining what is happening to the light after it interacts with each of those 2 types. Just like the lenses, you just have a little bit less resources, but it's pretty much the same thing. And you do have more videos on mirrors. Okay, the last main idea is going to be the stuff that you just did on Friday and Monday, the calculations. So I'll quickly review the formulas that are going to be on the board on the day of the quiz. And I'll make sure that you know what those units are. So the last main idea and question, I would say maybe, now let me get rid of that. Say optical formulae, which is plural for formula, or formulas, it doesn't really matter. Okay, so one of the formulas that's going to be on the board is the formula for the index of refraction. It's the quotient of the speed of light and the velocity through which the light is moving. Tricky thing about using this one is you have to know, well, I guess it's not this one. Let me come back to that. Another thing that you're going to be given is this isn't a formula, but it is a constant of nature's speed limit for information. Light is our primary source of information, and it can only travel through space at the rate of 300,000 kilometers per second. So if you want to know the index of refraction for a substance, you just divide the speed of light, the fastest that it can possibly go, by how fast it's moving in that substance. So the index of refraction for air is 1 because light pretty much goes this speed through air. It actually goes a little bit slower. But the main thing you should know is that the denser the material is, the greater the index of refraction is, because the smaller this velocity is. So as this number goes down, this number goes up. It's an inverse proportionality. You're not going to have anything on graphs and expressions and relationships this time. Most of your quiz is going to be about explaining processes and illustrating them and the calculations that we're about to, well, I'm not going to go over how to do it. I already did that in the last 2 videos, but using these formulas. Okay, so another formula that you're going to have is the image distance. Remember, this is for how far away something appears to be, is equal to the object's distance, how far away it actually is, multiplied by the ratio of the indices of refraction. So it's important that you know that this is the second one. So usually a good thing that might be worth writing down, the index of refraction for the second one, that's usually where the observer is. You think of it like the person who is seeing the image is in the substance with the index of refraction, with the second index of refraction. It's where the light ends up. Now where it starts out, this is the substance that the object is in. So this is where the object is located. The index of refraction of the second one is where the observer is located, or what substance they're in. Remember, this n right here represents, it has to do with the ratio of the speed that of the light that light could be going versus the speed that it is going in a given substance. And the second substance is for the person who sees the light. The first substance is the source of the light, or where the light originated after it bounced off of or reflected off of the object that is being observed, forming the image. Okay, the next equation is the big one. It's not too bad, but the algebra can be a little bit rough, so hopefully the repeated examples that I showed you have prepared you for success. Remember this right here, this is the focal length. This has to do with where light rays converge if they are traveling parallel to the principal axis, that line that goes right through the center of a lens or mirror. This right here, the object distance, and this right here is the image distance. So I can't really get too much further into this without giving you answers to other questions, but please look at some of those diagrams that I provided in the exercises. The reason why I copied I literally made copies of a bunch of pages, cut out all those diagrams, taped them onto a different page, and made all those copies, because I know that if you study those, if you understand how those relate to this equation, you will be so much more prepared for the quiz versus those of you that just skip to the end of the video, copy down what's on the screen, got 7 out of 15 of your homework problems done, never looked at it again, and essentially wasted paper and time. All right, last problem is the magnification factor. And it's just how much something has been magnified, how much larger it looks. That is the negative value of the ratio of the image distance and the object distance. So I talked about this negative sign and how it's not really that informative, but I'm just trying to be thorough in my presentation of the information. Other than this right here, this is all you need on the board. You will have to use the magnification factor, or actually 1/2 of you will have to use the magnification factor to see how much larger something appears to be, which means you're just going to multiply this value by however large the object actually is, so that you can see how large it looks to be for the observer. Only a quarter of you are going to have to use this information right here, but all of you will have to use this information right here. Now I want to talk about this equation in a little bit more detail on the next slide. So actually that's going to bring us to 10 main ideas in total. And we're only working on 40 minutes right now, so won't spend too much time on the next page. Hopefully you'll get some time to summarize your notes and maybe gather all the resources that you should be pulling information from, because I doubt you will be able to do this while I'm talking about all this stuff. This video, I'm not telling you what you're writing down in your notes. I'm telling you where to find the information to write down in your notes. So, last main idea and question is the thin lens equation. But it doesn't just work for lenses, it also works for mirrors. This is just known as the thin lens equation. I mean, obviously the exercises we did on Friday, the calculations review that you did on Monday, and there is a video from April 11th that goes into, or that it's an example of somebody else solving this. So, if my examples weren't that helpful, if you still feel confused, check out that video. I think it's maybe 5-10 minutes long. The person does a really good job at showing how to use it and showing how the pictures relate to it. All right, so when it comes to the thin lens equation, there's a couple things that I want you to know. And I wrote these down yesterday, but it's worth repeating because it will be the difference between getting a point and possibly the grade that you want. Main thing you need to know is if you calculate I to be less than 0, then you need to know that the image that has been formed is virtual and upright. Oops. Sometimes also called erect, just means standing straight up. Another thing that you need to know when it, well, I guess might as well write down the converse. If you calculate I to be greater than 0, then the image is real and inverted. So that means that the light rays are actually coming together and the object appears to be upside down from the observer. Over here, if it's virtual, the image or the light rays only appear as if they came from a certain point, and the object appears to be upright or erect, standing straight up to the observer. So this is if you calculate I to be positive or negative. Now, sometimes you're not going to calculate I. Sometimes you have to put I into an equation, and I'm not giving you whether it's positive or negative. You're going to have to figure that out. So let me give you a couple rules. If you have a concave lens or a convex mirror, the image is always virtual and upright. So essentially what that means is if you're working with a concave lens or a convex mirror, and I just gave you some points for one of your other questions, then you know that your I is going to be negative, guaranteed for sure. Now the opposite is true over here. Well, no, that's not true. I'm sorry. Take that back. So I'm going to need to continue on with this main idea. There's more rules that I want to cover. Let me see if I can just go down a little bit. Okay. So when it comes to a convex lens and a concave mirror, there's some rules. So if you have a convex lens or a concave mirror and the object's distance is less than the focal length, then the image is always virtual and upright. So I'm pretty much giving you the notes for this one. If you made it this far in the video, you should be writing this stuff down because it is going to make your life easier for those two problems. A couple other rules I want to write down, and I'm going to have to do this on the next page. So let me continue on here with the same main idea. And we'll wrap this up in the next 5 minutes. So, if your lens is convex or your mirror is concave and your object's distance is greater than the focal length, then your image is real and inverted. So, when it comes to these two cases, a convex lens and a concave mirror, if you have a real inverted image, for the lens, and this is a continuation of this condition right here, when O is greater than F, when the object is further from the lens than the focal length, your lens is going to, or I'm sorry, let me backtrack a little bit. So, oh yeah, I'm sorry. If you have a lens, then the image is on the opposite side of the object. And if you have a mirror, then the image is on the same side of the object. So I probably should have backed it up. If the lens is concave or the mirror is convex, so let me write a new rule here. So when we're talking about concave lenses, so this is kind of all, this is a point here, and this is a point that goes with this right here, but this is a brand new condition here. You have a concave lens or a convex mirror. So when it comes to a concave lens, the image is on the same side as object, and that's always true. And if it's a convex mirror, the image is on the opposite side of the object. Okay, this stuff right here, you know, you don't really need to like memorize these conditions if you understand those pictures. So please take my advice and check those pictures out. The other thing, one more thing that I want to say, and we'll just try to fit this in, whoops, the bottom here. Oh, well, let's pretend like this top right here is the bottom. We'll just bring this line up. So one final thing I want to end this on. If you have a convex lens or a concave mirror, your focal length is always going to be greater than 0. And that's because light rays that are passing parallel to the principal axis are always going to well, I guess when it's a lens, they're always going to pass through the other side. When it's a mirror, they're always going to pass through the same side as the object. But we always treat the focal length as a positive value when we're dealing with real objects that can create real inverted images. Now, if you're dealing with concave lenses or convex mirrors, the focal length is always less than 0. Okay, I'm going to have to end it there. It's been 50 minutes. I want to make sure you have 5 minutes for your do now and 5 minutes for your reflection. So study hard for that test. I hope you all do well.